Welcome back everyone, we're going to be solving LeetCode 994, rotting oranges. We're given an n by n grid where each cell can have one of three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. We want to return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, we want to return -1. Okay, so let's make this a bit bigger so we can see here. If we take a look at example 1, right, we have an output of 4. It takes 4 minutes to make this grid rotten. So we start with 1 orange in the top left corner. The first minute, these next 2 oranges will be rotten. The second minute will rot these next 2 oranges. The third minute will rot this orange, and the last minute will rot the last orange. So since we're grabbing 4 directionally adjacent oranges, we are going to use a breadth first search approach. So let's get that set up. We'll say from collections import DQ. We will set that up to be a Q, DQ, and breadth first search, right, we're going to use a visited set to make sure we're not visiting columns multiple times. So we'll say visited is going to be equal to a set. Now we're going to want to keep track of an output time, right? We need to know how long it takes to rot all the oranges. So we'll say count is going to be equal to 0, which is what we're going to be returning. We also want to keep track of how many fresh oranges there are. So we'll say fresh is going to be equal to 0. And let's see here, that should be it. Okay, so now the first thing we need to do is loop through the grid and find out if we even have rotting oranges already in order to start the breadth first search. So we'll loop through the grid initially. We'll say for row in range length of grid, for column in range length of grid 0. We'll say if grid of row column, if that is equal to a 2, which is a rotten orange, we are going to say q.append the row column pair. We're also going to check to see if it's a fresh orange. So we'll say if grid of row column is equal to 1, then we want to say fresh plus equals 1. Okay, after we loop through our grid, grab all of our rotten oranges, if any exist, and increment our fresh oranges, right, the first thing we want to do is check, okay, well, what if our entire grid already consists of rotting oranges? Well, then we should just automatically return 0, right? And this is example 3. There are already no fresh oranges at minute 0, so the answer is 0. So the first thing we're going to want to do is check, okay, if fresh is equal to 0 after this loop, then we just want to return 0. Otherwise, we're going to go ahead and implement our breadth first search. So we'll say, while the length of our queue is not equal to 0, we are going to loop through all of our rotten oranges. We'll say for I in range length of our queue. We will grab the row column pair with q.popLeft. Now, we want to take this row column pair, right? And we'll say if that row column pair is a fresh orange, then we want to make that orange rotten. So we'll say if grid of row column is equal to a 1, then we want to set it equal to a 2, which is a rotten orange. We also want to decrement our fresh oranges, right? So we'll say fresh minus equals 1. Now we need to grab the 4 directionally adjacent cells, right? So we'll say if row plus 1 is greater than or equal to 0 and less than the length of our grid, and our column is greater than or equal to 0 and less than the length of our grid 0. and the row plus 1 column is not in visited, and grid of row plus 1 column equal to a fresh orange, right? We only want to place fresh oranges onto our queue. If that is equal to a 1, then we will say visited.add a row plus 1 column and queue.append the row plus 1 column pair. Now we want to do the same thing, but instead of the next row, we want to check the previous row. So we'll copy this, change all of these pluses to 1s, like so. And now we want to check the next column. So we'll get rid of all of these. And just increment our columns instead with plus 1. And now we want to check the previous columns. So we'll copy this and change all of the pluses to minuses. Perfect, okay. Now, once we do that, we need to check, after we exit this for loop, right? We need to check if we still have fresh oranges, right? So if fresh is not equal to 0, we're going to increment our count by 1, right? And we still have to keep incrementing our count because we still have oranges left to rot. Now, after we exit this breadth first search, we need to say, okay, if fresh is not equal to 0, that means when we implemented our breadth first search, we were unable to rot every single orange within the grid. If that is the case, we want to return -1. So we'll return -1. Otherwise, we're just going to return the count, right? However long it took us to make all of the fresh oranges rotten. So that should be it. Let me just double check my work here. Okay, perfect. This is looking nice. Let's run it. Perfect. We passed all 3 test cases, so we'll submit. Awesome, and it does run. So, okay, time and space complexity for this problem is going to be O of R times C for both. All right, that'll do it for LeetCode 994.